Hi, everyone. In case you don't know me or recognize me because you're in Mr. Wong's class, I'm Mr. Thomas. I'm the other 7th grade math teacher at Willard. And me and Mr. Wong are we're going to take turns making these videos for all Willard 7th graders to help you with Desmos homework. So this time it'll be me. I'm going to go through the practice problems for Unit 7.2, Lesson 2 with you. So let me share my screen. Okay, and let's see, maybe let me turn the light on, let it focus a little bit. All right, so let's start with the warm-up. The warm-ups feel very disconnected from the rest of the questions because the questions we're working on right now are about proportionality and values in ratio tables like this, right? And constants of proportionality and equivalent ratios, right? So why are they asking us to do this like algebra at the top? Well, the math looks different, it's presented in a different manner, but it's actually the exact same idea, right? If I ask you 2 times some number that we don't know, which we're calling x, equals 7, well, that's the same thing as if I'm in one of these tables and I put a 2 on the left and a 7 on the right, and I ask you, what's the constant of proportionality here? What number do you have to multiply x by in order to get y? It's the exact same like method of thinking, just presented differently. And it's just kind of how math is connected in that way. Like you could be working on all these different things, but the skills involved actually wind up being the same a lot of the times. So, all right, let's do it. So 2 times x equals 7, or sometimes some students like to think of it better as like a blank, 2 times blank or 2 times unknown equals 7. Well, some people could just fill that in with their head. If you can't, then you can always work backwards, right? If 2 times blank equals 7, then it follows logically if you understand the reverse relationship or inverse relationship between multiplication and division, that 7 divided by 2 should be able to fill in that blank. So 7 divided by 2 equals blank. Sometimes I'll write 7 divided by 2 as, let me zoom in a little bit, as with a division symbol. Sometimes I'll use fraction symbols. I like to switch back and forth between those things. So you could punch this into a calculator if you wanted to. I'm going to use my phone calculator periodically throughout this exercise. Or you could just write it as the fraction 7/2. 7 over 2 represents 7 divided by 2. I happen to know that it's 3.5. So in this case, the blank or the variable, the solution to this equation, whatever you want to call it, happens to be 3.5. And we could check that, right? 2 times 3.5 equals 7. If you're not sure, please go and check it. Just punch it into a calculator. All right, so next, 60 times blank or 60 times some unknown number equals 6. Well, obviously it's going to be a really small number, right? 60 times something equals 6. That's going to have to be a really small number. So it's tempting to want to say the answer is 10, right? But that would mean that you're thinking backwards. 10 is going to be involved though. So using the logic from the previous exercise, we now know that if we want to fill that blank, let's just work in reverse. Let's do 6 divided by 60. And this time I am going to write it as a fraction. I'm going to write 6 divided by 60 as 6/60ths. And instead of like thinking of it as a decimal, let's do it as a fraction this time. I can simplify this by dividing this fraction by 6 on top and 6 on bottom, aka 1, just written as 6 over 6. And this gets me 1/10. So x in this case equals 1/10. Sorry, I wrote that so weird, like the equal sign next to the 1 instead of the middle of the fraction. It's weird. I don't know why I did that. Okay, so next we have 12 times some number equals 48. I feel like this is one you could probably fill the blank in your head if you really tried to think about it, right? Like, how many 12s do I need to make 48? Or what's 48 divided by 12? Those two things mean the same thing, right? Let's just do it. 48 divided by 12. 12, 24, 36, 48. I had to count by 12 4 times. So you want to notice something weird? My document camera has this weird thing about making my hands look super red. They're not that weirdly red regularly, but it's so weird. I don't know why it does it. Anyways, all right, so the last one, x times 1/20 equals 1. This is another one you could probably do in your head if you thought about it enough, right? Like, what do you have to multiply 1/20 by? Let me move this over a little bit in order to make one whole. So you need 20 20ths, right? 20 1/20 to make one whole. But let's do it in a weird like division way just to see the kind of the weird way to get this answer. 1 divided by 1/20. Well, you should know keep, change, flip, right? Where if I keep the first fraction, let me write 1 as a fraction. I'm going to write 1 as 1 over 1, right? And I'm going to keep, change, flip. Where I'm going to change this division problem into a multiplication problem by keeping that first fraction, changing to multiplication, so division becomes multiplication, and then flipping that 1 over 20 to 20 over 1. And now it's super easy, right? 1 over 1 times 20 over 1, that's just 20. Right? 1 times 20 is 20. 1 times 1 is 1, it's 20. So in this case, x equals 20. So those same skills, that same idea of, if we need to know what number times this number equals this other number, let's work in reverse, let's divide it. That's going to really help us in working on filling in these missing values in these ratio tables. I think of them as ratio tables just because I imagine whatever x is like representing some quantity, like maybe green paint or white paint from our Desmos, or sides of a drawing, like scale drawings, or flour to sugar if you're talking about a recipe. And so like I think of the numbers as representing ratios between these two quantities, like 30 parts to 3 parts, 120 parts to however many parts. All right, so we can keep these ratio tables proportional as we move through the rows by establishing the constant of proportionality using any row in which we know an x value and we know a y value. So hopefully you've learned this in class already, that if you need your constant of proportionality, which is kind of weird, it's the constant, which that word starts with a C, but we always abbreviate it with the letter K just because C has other special meanings in math and science, so we try not to use C. Well, we can always find our constant K by doing a y value divided by an x value. I've got a y value, I've got an x value, let me do it. 3 divided by 30, or 3/30 is how I like to write it. I know that that simplifies to 1/10. And so my K, or my constant of proportionality in this case, is going to be 1/10, meaning any x value I have, as long as I multiply it by 1/10, I'll get the corresponding y value. So 120 times 1/10 equals, multiplying by 1/10 is easy because it's the same as dividing by 10. And when you're working with tens, you just move the decimal point, you know? So 120 divided by 10 is just going to leave you with 12. All right, so the way the constant of proportionality works when dealing with x and y values in a left column and a right column is that whatever your x is times the constant of proportionality is going to equal your y value. But we have to reverse that relationship in order to work the other way, right? Just like scale factors in scale drawings, like if you have the scale factor to go from one drawing to the other, then you need the scale factor to go back the other way, you flip it. It's sort of the same thing with constants of proportionality. We could flip our constant of proportionality and turn it into 10 over 1 instead of 1/10, and then multiply across, or you could also think of it as dividing by your constant of proportionality in order to go from y to x. Either of those two ways of thinking about it are okay. So I'm going to think of it as dividing. I need to do 10 divided by 1/10 in order to fill that box, because I'm moving from y to x, so I got to divide. Well, I'm thinking keep, change, flip again. This is the same as 10 over 1 times, now I flip this 1/10 to become a 10, equals 100, right? 10 times 10 is 100. And that makes sense, because if we took 100 and multiplied it by 1/10, we would get 10. All right, so let's do the same thing here. Let's establish our constant of proportionality first, right off the bat. This one's easy. because I'm given this 1 right here in the first row. So when I do y divided by x, it's going to be 1.5 divided by 1. Any number divided by 1 is just itself. So the k in this case is 1.5. They basically gave it to us on this one. And so now if I take this 3 and multiply it by 1.5, that's a multiplication dot right there, trying not to use x's to mean multiplication because x's look like variables. Well, 3 times 1.5 is 4.5. And then to go back that other way, to go from y to x, I need to divide 12 by 1.5. So let's see here. I wish that they give me more room to work here. You know what, how about, no, I'm gonna do it. I'm gonna do it this way. I'm gonna do 12 divided by 1.5, but I'm gonna just write it here like this and draw an arrow over there. That one, I don't know if I can do in my head. All right, let's use a calculator, no big deal. Let's see here. Now I clear the last thing I did. All right, 12 divided by 1.5 equals 8. Okay. And so now, just to check the relationship to make sure it works, 8 times 1.5 equals 12. That I can do in my head. And yeah, that works. We got it right. All right, cool. Next one. Let's find our k, our constant of proportionality, right off top. So we've got 45 for y, 15 for x. If I need my k, I do y divided by x. Don't accidentally do x divided by y. So 45 divided by 15. I'm just thinking about that in my head. I'm counting by 15s. 15, 30, 45 goes in 3 times. That's 3. Good, a nice easy one, 3. Okay, so if I have 1 in my x value, I multiply it by my k. 1 times 3 is 3. Okay, and then, well, this one's a little weird. They put a 0 way down here, so the values are like sort of out of order. Whatever, I don't know why they did that. All right, so I have to, if I want to go from y to x, I gotta divide by my k, right? So 0 divided by 3, that would look like this as a fraction. That's still just 0. So if I have 0 for y, I gotta have 0 for x. I think you'll find that that's always, always, always true. All right, in a proportional relationship, I should say. All right, the last one. I've got 0.2 for x here, and I've got 1 for y. I could divide here. I could do like 1 divided by 0.2, and I would get the right answer. Let's try it this way instead. What if I just try to fill the blank in my own head, right? Like 0.2 times some number equals 1. Let me just count by the 2s. So 0.2, 0.4, 0.6, 0.8, 1. So if I had 5 of these 0.2s, I would get 1. So I think my k in this case is going to be 5. And so now 1 times 5 equals 5. And then for that last one, I got to go from y to x, so I divide, or I could think of it as multiplying by 1/5. Either of those work. And so 20 times, in fact, I'm going to write it that way this time. 20 times 1/5. It's 1/5 of 20. Well, it's the same as if I divided it by 5. That's easier to think, right? 20 divided by 5, 4. All right, moving on. Down here below, let me see if I can get this sort of aligned good. Hey, there we go. It says entrance to a state park costs $6 per car plus $2 per person in the vehicle. Okay, complete the table. Oh, all right, this table right here. I was about to say I don't see a table. It's literally right in front of my face. Okay, so if there's 2 people in the car, well, first they pay $6 for the car off top, right? Like that's for the ability to just drive the car in. But then they count how many people are in the car. In this case, it's $2 times 2 people. So this is going to be the 6 for the car plus 4 for the people equals 10. So I'm going to put a 10 here. Okay, then if we had 4 people, it'd be 6 people for the car plus 2, 4, 6, 8, right? For 4 people, that would be 14. And then if I had 10 people, that's a big car. I don't know what they're driving. Okay, so $2 times 10 people, that's 20. Plus they have to pay the 6 for the car itself. That's 26. All right, so the next question says, how might you determine the entrance cost for a bus with 50 people? Well, probably through the same process I was just kind of talking through out loud, right? I would do 50 times 2, right? This is people, and this is dollars per person. And I would probably do that first. You don't have to do that first, but I don't know, I probably would. So I'll put it in parentheses, right? That means do this first. And then I would add the $6 for the car. And so 50 times 2 is 100 plus 6, 106. Is the relationship between the number of people and the total entrance cost a proportional relationship? I'm not sure. Well, I know that if it were a proportional relationship, then the ratios between the number of people in the car and the cost would have to stay the same. There would need to be a constant of proportionality, this number, k, that if I take the number of people in the car, which let's label this as x, we'll make the stuff in our left column x and the stuff in our right column y. I should be able to take any x value, multiply it by this special number, the constant, and get the y values. And if I can't do that, if that doesn't work, then it's not proportional. So here I see that I was about to use an x for multiplication. Let me change it to a dot. 2 times blank equals 10. That's easy enough. That's 5. So when you bring 2 people, you're paying $5 a person, basically. I mean, you're paying for the car and the people or whatever, but it works out to $5 per person. But if you bring 3 people, 3 times blank equals 12. Well, that's not 5, it's 4. That's a problem because now we don't have a constant of proportionality. We don't have this one singular number that I can always multiply the x by and get the y value. The value is changing, right? It's like the more people they bring, the cheaper it is per person. Like they're saving money as they go. That's sort of called like bulk pricing, and that's not a proportional relationship. So explain how you know. So I would say, no, this is not proportional because the ratios are not equivalent. And then let's be specific about like which ratios I'm talking about here. So I filled this in with a 5 because I figured out 2 times 5 equals 10, but really I was looking at the ratio between 10 and 2. I was looking at 10 over 2 equals 5, and then I checked that next ratio down. Oh, I'm just a little bit off the screen here. And then I checked that next ratio down between, this thing's giving me a hard time. Now you can see the thing in the, all right. So then I checked the ratio between $12 and 3 people, right? And that simplifies to 4. And so the fact that these two ratios are different tells us that there's no constant, right? Constant means doesn't change. This number multiplying across the rows is supposed to not change in order to be a constant of proportionality. So therefore, there is no, I'm just going to say K. Remember, that stands for constant of proportionality, the letter K. All right, let's move on. I'll readjust this thing so we can see the top of the screen. Working on kind of a small desk here. Give me a second. There we go. Back to orange for a little while. A bakery uses 8 tablespoons of honey for every 10 cups of flour. Okay, so we got an 8 to 10 ratio. Some days they make bigger batches and some days they make smaller batches. All right, so let's complete this table. Make sure that we keep this ratio between honey and flour proportional so they're, what is it, biscuits, bread dough, so the bread dough turns out good. Okay, so let's establish our constant of proportionality right off the top. If we think of these as our x values and these as our y values, then in order to find a k, constant of proportionality, we want to take a known y value and divide it by its associated x value, the x value right next to it. Okay, so I got a 10 and an 8. I'm going to do 10 divided by 8. I'm going to work with fractions. You could punch 10 divided by 8 into a calculator and get 1.25. I think it works out too. Instead, I'm going to simplify it to the fraction 5/4, right? I just divided the top by 2 and the bottom by 2. I'm gonna work with 5/4 just to do some fraction stuff. All right, so I got to do 20 over 1. I'm going to write that as a fraction to help myself, times 5/4, my constant. And so 20 times 5 on top gets me 100. 1 times 4 on bottom gets me 4. So it's 100 over 4, which means 100 divided by 4, which is 25. All right, let's do it again. 13 over 1 times 5/4 equals, well, 13 times 5 is 65. And 1 times 4 is 4. Okay, this one's not going to come out to a nice whole number because I know 4 doesn't go into 65. But let's see here. 4 goes into 64. I just have to know that off the top of my head. It goes into 64 16 whole times. So this equals 16. And then since that would make a 64, and we've got 65/4, 1/4 left over. 16 and 1/4. All right, and then the last one. So I need to go from y to x this time. So I have two choices. I can divide by 5/4, or I can think of it as like a keep, change, flip mentally and just go, okay, I'm going to multiply by that reciprocal, that 4/5. I'm going to do it that way. So I'm going to multiply 20 by 4/5. 20 times 4 on top is 80. 1 times 5 on bottom is 5. So I got to do 80 divided by 5. Now let's see here. I know if it was 75, that's 15. I can do that one in my head quickly for some weird reason. And I know that 5 more makes 80, so it's got to be 16. I'm like outside the box, so I'm going to put it over there. All right, so the last thing is this explore thing that kind of looks like a crossword puzzle where you got to find these patterns. I think both me and Mr. Wong decided that this is going to be extra credit for both of our classes. So if you want to tackle this, go for it. Give yourself that challenge. If you don't, then you can skip it. All right. See you next time, you guys.